go. Right, I'm going to have a bash at this question. It's from the AQA Specimen Paper 1 for AS level maths. So because it's AS level, it should be accessible for all year 1 students. So let's have a look at it. So we've got a parallelogram with side lengths 6 and 4.5. So let's draw a parallelogram with side lengths of 6 centimetres and 4.5 centimetres. Sorry about the awful parallelogram. The larger interior angles, that's that one and that one, have size alpha, so they're opposite each other. Opposite angles are equal in a parallelogram, so that's quite important. Okay, given that the area of the parallelogram is 24 centimetres squared, find the exact value of tan alpha. Okay, so if we cut this in half, then if we can work out the area of one of these triangles here, and we double it, that should equal to 24. Okay, so if we just take one of the triangles like so, okay, because we can't, if we wanted to use the area of a parallelogram formula, we'd have to find that perpendicular height there, and we don't know that, so we're going to use half AB sine C to find the area of that shape there. So a half AB, okay, and sine C. So these two sides are either side of the angle that we know, so that's all right. So we can do a half times 6 times 4.5 sine alpha. Now that's the area of one of those triangles, okay? But we want the area of the parallelogram, so we need 2 of those. So the area of the whole parallelogram is that times 2, because we've got 1, 2 triangles. Okay, so a half times 2 straight away. So we've just got the area of the whole thing, which is equal to 24, we are told in the question, is equal to a half, 6 times 4.5 times 2. So we can get rid of that and that. Okay, so 6 times 4.5 is 27. Yeah, 9 times 3. So 27 sine alpha. So if we rearrange that a little bit, we know that 24 over 27 is sine alpha. And then we can use that neat little trick here now. Well, it's not really a trick, is it? But sine is equal to, sine of alpha is equal to opposite over hypotenuse. Okay, so from here, the opposite of, let's call this angle here alpha, the opposite of this is going to be 24. And the hypotenuse is 27, because opposite over hypotenuse, that's the opposite, that's the hypotenuse. Okay. Oh, sorry, that should be 27 there. Come on, Louise, what are you doing? Right, so to work out tan alpha, we're going to need to work out that adjacent side there. This side here, this adjacent side here. So how are we going to do that? Well, we're going to use a bit of cheeky Pythagoras. So that side there, should we call it, should we just call it x? We can use Pythagoras. 27 squared minus 24 squared equals x squared. And pop that in Captain Calculator. And that will give you your missing value. Now, where's Captain Calculator gone? He's been away all summer. Okay, we'll use Big Computer. So 27 squared take away 24 squared is 153. So x squared is 153. I'm not very confident with my numbers here, by the way, because I'm doing this on a terrible, terrible computer. So x is equal to root 153. Okay, now, if we do the square root of 153, it's 12 point something. I'm trying to think if there's any square numbers in there. So 153, can we divide it by 4? No. Can we divide it by, well, we can't divide it by 5. Can we divide it by 3? Why did I start with, yeah, it's 51 times 3. Now 51 is 7, right, okay. So 153 is 9 times 17. So that is the same as 3 root 17. Oops. Now you've got a calculator, that will do it for you. I'm trying to do this in my head. Okay, so now we know, looking from our triangle, that tan alpha is equal to the adjacent, which is our x value, which is 3 root 17, over No, it's not. Tan is opposite over adjacent. No, it's tower. Yeah. Tan is opposite over adjacent. So it's 24 over 3 root 17, which is the same as 8 over root 17. Okay, and I think the question was asking us to find the exact value of tan alpha. We can't get much more exact than that. They might want that to be rationalised. So you times top and bottom by 8 root 17, which will give you, sorry, just by root 17. God, you can tell I've been asleep, can't you? So that would just give you 8 root 17 over 17. And I think that is what we're after. If you check the mark scheme, boop.